There we go. Okay, so we're going to talk about some parent graphs. These are functions that just show up a lot. They're almost like our most common functions. You guys remember in geometry how you had to memorize like some triples like 3, 4, 5, 5, 12, 13, because those were the most common ones of the Pythagorean triples. So this is sort of the same as some of these parent graphs that we want you to memorize. I want to change this into graph paper. Okay, so our first one that we need to have memorized is y equals x squared. Does anybody know what this is? Who knows what this looks like? In the back, what's your name? Luke? It is. It's a parabola. It's a parabola with a turning point at 0, 0. So this is a parabola that is smiling. Do you know how we make the parabola frown? Do you know how to make the parabola frown, what we put in front of it? A negative, perfect. So if I then go to y equals the negation of x squared, now we are taking that parabola and we are reflecting it over the x-axis. So now it is a parabola that is frowning. Okay, so that's the first parent graph you have to memorize. The second parent graph that we have to memorize let's not draw it yet, is the absolute value. So y equals the absolute value of x. Now, when we have an absolute value and the degree of the variable inside is 1, what do I mean when I say the degree of the variable inside? Anybody know?
It's not like to the second power.
Good. It's meaning its exponent, like the highest exponent on a variable is 1. That's telling us this is going to be an absolute value which looks like a v. And let's talk about why that is. You guys don't have to draw this part, but let's just talk about why the absolute value of a polynomial with a degree of 1 in there is going to look like a v. Do we all agree y equals x is a line? Y equals x is a line. It looks something like that. Okay? Now, if I were to take this line and I would take the absolute value of it, what does that mean? Nothing can be under where x equals 0, right? Everything then has to turn positive. When you take the absolute value, something turns positive. So essentially speaking, we're taking this whole area. We're taking this whole area and making it positive. How do we make that whole area positive? Ends up looking something like that. Makes sense, right? So when we have an absolute value of an x with a degree of 1, it's going to look like a v. And we can make the v frown by putting a negative in front of it. Let me show you where. Not inside the absolute value, because inside the absolute value it turns everything positive. So we want it outside the absolute value. So y equals the negation of x. of the absolute value of x. And that looks something like this. Oh, sorry guys, I forgot to talk about the domain and range here. What is the domain of a parabola? What's the domain here for the first one? Buddy? Nico?
It's all reals.
Yeah, it's all reals, right? X such that all real numbers.
Oh, yeah.
What about the range? So remember, the x is the domain is the x, the range is the y. What's our range here? Luke?
Greater than 0.
Could it be equal to 0?
Yeah.
Yeah, greater than or equal to 0. You got it. All right, let's talk about our domain for our frowning parabola. Is it still all reals? Yeah. But now our range is different. What's our range for this? Erin?
Less than or equal to 0?
You got it. Y such that y is less than or equal to 0. Okay, our domain for our absolute value here is all reals. And our range is y such that y is greater than or equal to 0. So it's pretty much the same as the parabola. And when we make our v frown, our domain, similar to the parabola, is all reals. And our range is y is less than or equal to 0. So far, those are the two parent graphs, the parabola and the absolute value. Let's go to our third one. Yes?
Can you scroll up a little bit? I'm trying to get another question.
Sure. Like here? You good, Nico?
Yeah, I'm just.
Okay. The next one, the next parent graph we want to memorize is y equals the square root of x. Y equals the square root of x. Before I even sketch this, you tell me, there is a restriction on the domain. What is the domain here, since you guys are all domain experts at this point? What do we know? X must be what? Charles?
Positive.
It must be positive. Therefore, x has to be greater than or equal to 0. Remember that? Okay, what this looks like, the square root, I call it the shooting star. And what the parent graph looks like here is we're starting at 0, 0, and then we're shooting off to the right. All right, what's the range? Looking at the graph, what's the range? Somebody besides Erin. Somebody else, and not Luke. Somebody different. You got it. Y such that y is greater than or equal to 0. Are you guys having a hard time recognizing it from the graph, or are you all just tired and not participating? Okay, good. So now let's talk about the negation of this. So we had y equals the root of x. Let's talk about y equals the negation of the root of x. So again, similar to the parabola and the absolute value, you're reflecting this. You're reflecting this over the x-axis. So if I take the shooting star and I reflect it over the x-axis, it's sort of like folding it over the x-axis. It's just going to be shooting down. So it looks something like that, a shooting star going down. My stylus is all messed up, that's why everything is shaky. So the domain here is all real, no, not all reals. X is greater than or equal to 0. And our range is y is less than or equal to 0.
This would be how you find the domain and range from the graph by itself.
Oh, okay. So domain is left to right. So let's go back to the parabola. So you look, okay, what's the furthest left I go? Isn't it an arrow?
Yeah.
So that's like negative infinity, right? What's the furthest right I go? Isn't it another arrow? So that's positive infinity. So when you're going from negative to positive, that's all reals. All right, same thing for the v's. So now the range is the y. So now for the domain, you're looking furthest left, furthest right. For range, you're looking bottom to top. So what's the lowest point here? Our lowest point is 0. It's included because it's part of the graph. What's our highest point? Arrows. So that's positive infinity. So it's going from 0 to positive infinity. So that means it's greater than or equal to 0. Good? Do you want me to show you on the shooting star, or you get it now?
I got it.
You got it? Okay. All right, so that was 3. We have the parabola, we have the absolute value, we have the shooting star. The very last one is what I call the disco dancer. Y equals x cubed. I'm so bad at drawing the disco dancers. So it sort of like comes and then turns and goes up, but it should be turning at 0, 0. This one more time. It's because my pen is shaky. There we go, that's the best I'm going to get. There's our disco dancer. Our domain is all reals. Our range is all reals. So now let's negate this disco dancer. What happens when we negate the disco dancer? So if I have y equals the negation of x cubed, so before we're going from quadrant 3 to quadrant 1, when we negate it, we're going from 2 to 4, or 4 to 2, however you want to look at it. We're just sort of turning him. Do this again. But our domain and range are unchanged. Our domain is all reals. Our range is all reals. Oh, sorry, there is one more. There's one more paragraph I need you to memorize. Can I go to the last paragraph? So here we have y equals 1 over x. This is called a rectangular hyperbola. And there's definitely a restriction on our domain here. Before I graph it, if I have 1 over x, what do we know x cannot equal? X can't equal 0, exactly. So our domain is basically every number could work except 0, right? So it's every number, it just x can't equal 0. Every number is okay. So this creates an asymptote. This creates an asymptote at x equals 0. So here we have x equals 0. And in a rectangular hyperbola, there's another in the parent graph. There's another asymptote at y equals 0. And do you see how I'm drawing these asymptotes? What am I drawing them with?
Colors.
Well, colors, but more importantly, what kind? How am I making the line? Dashed. Yeah, asymptotes are always drawn with dashed lines. So that's important. So in a rectangular hyperbola, in our parent graph, we have our graph in two areas. We have it in quadrant 1 and in quadrant 3. So basically what's happening is we are getting really, really, really close to the x and y axes, but we're never crossing them. Do you see how I'm like hugging it, but I'm never crossing it? I'm not crossing it because of the asymptote. So then we're going to do the same graph in quadrant 3. Get really, really close, but don't cross. Yes? Well, here, y will never be 0 because you have a numerator of 1. There's no variable up there. So is there any way, the only way to make this equal 0 is if the numerator were 0, and can we ever make the numerator 0? No. Okay, so that's our rectangular hyperbola. Guess what I'm going to show you now? I'm going to take that rectangular hyperbola and do what to it? Negate it. So y equals the negation of 1 over x. Yes?
For the, like the positive one, why is it the first over part? Not part, it's like...
Well, it's just sort of how the parent graph looks. Like we're going to shift it all over the place. It's not saying it will never end up in the second or shifting anywhere, but if you want to, you can plug in numbers and see that that's where the points just end up lying. So for example, if we have y equals 1 over x, that's our equation. So we have x, y equals 1 over x, and then our corresponding y coordinate. Let's say I plug in a 1 for x. If I plug in a 1 for x, we're going to have y equals 1 over 1. Well, what's 1 over 1? 1. So that gives us the point, like, 1, 1. And that's really how, depending on the point you plug in, it will always be in this area or this area. There won't be anything in these two areas. Okay, let's negate this. And now when we negate it, we're still going to have that same domain. Oh, sorry, what was the range for this one? Our range was y cannot equal 0. Oops, why such that? Okay, now we're negating it. Our asymptotes are going to be the same. That sounded like a real dog. All right, now this time when we negate it, we're not going to be in quadrants 1 and 3 anymore. Now we're going to be in quadrants 2 and 4. So we hug it, but never cross it. Hug it, but never cross it. So our domain, similar to the first one, x cannot equal 0. And our range, similar to the first one, is y cannot equal 0. What do you think I need from you in terms of these parent graphs? What do you think I need you to do? Memorize it. I need you to memorize these parent graphs. I need you to memorize all of them. Okay, so now what we're going to do, we're going to shift these parent graphs. And the good thing about all of these parent graphs, they sort of follow the same rule of shifting. So once you memorize the parent graphs and you memorize the rule for shifting, it applies the same way to all of the parent graphs. All right, let's talk. So I'm going to do them individually first, even though it's always the same rule. So let's talk about shifting the parabola. So our parent graph is y equals x squared. Do we agree? All right, so now let's talk about the translation. If you take your parent graph and now you have the format of y equals a, open your parentheses, x minus h, close your parentheses, squared, plus k. Okay, so A is going to tell us, for the purpose of this class, the only purpose A shows for us is if it's going to be a frown or a smile. That's what A. So if it's positive, it's a smile. If it's negative, it's a frown. So A positive, open up. Negative, open down. Okay, H is going to be our horizontal shift. Horizontal shift of turning point. Now notice in my sort of like formula format, see how it's x minus h? Well, when it's x minus h, that's actually our positive form of this. So when it's x minus h, we're shifting to the right. So it's sort of counterintuitive of what you think. So when it's x minus h, we're shifting to the right. If it's x plus h, guess where we're shifting? To the left. Thank you. All right, so let's write that out. X minus h, shift right. X plus h, shift left. All right, and the next one, K. So K is going to represent the vertical shift of the turning point. Vertical shift of turning point. But now look in our formula format, right? Our formula equation, it's a plus K. So in the formula, if it's a plus K, so that means if it's plus K, you go up, and guess what? If it's minus K, you go down. So plus K, you go up, minus K, you go down. All right, do we want to try one where we sketch and shift?
Not really, but
We got this.
let's go.
Here, I'll give you a minute to finish copying. Are we ready now? Okay, let me zoom in. Let me make this bigger. Okay, so I want us to sketch y equals, this is an example, y equals in parentheses x squared, x plus 1 squared, close your parentheses, squared, plus 2. So the first task you have to give yourself when I'm asking you to create your own sketch is you're going to look at this and you have to now relate it to one of the parent functions, one of the parent graphs. So right now I'm relating this to the parabola because it's an exponent of 2. If it were an exponent of 3, it would be the disco dancer. If it was square root, it would be the shooting star. If it was an x in the absolute value lines, but the x only had an exponent of 1, then it's the v. Okay, so your first task that you want to give yourself is look at this and say, okay, which parent graph am I relating this to? We're relating this to the parabola. Now, just to show you, I'm going to sketch the parent graph. If you don't want to, you don't have to. I'm going to sketch it and then shift it. So the parent graph looks something like this, right? This is my turning point at 0, 0. Now, according to my rules of translations, I know that it's going to stay a smile. How do I know that it's going to stay a smile, Nico?
It's not negative.
Because it's not negative in front of the parentheses. So good, we're staying a smile. Then, remember, inside our parentheses is our horizontal shift. And then at the end is our vertical shift. Now, our format is we want x minus h squared plus k. So remember, it's supposed to be a minus in the parentheses. Since it's a plus, am I going to shift right or am I going to shift left?
Left.
Left, because it's a plus h, we're shifting to the left. So I'm going to take my turning point from my parent graph, and I'm going to shift 1 unit to the left, and then how many units up? 2 units up. So I'm taking my turning point, and I'm shifting 1 unit to the left and 2 units up. There is my new turning point. Oops. I'm erasing my old graph now. And then we just make our parabola. It's not going to be completely accurate. This is just a sketch. It's just an idea of how it's going to look. It's not going to be 100% accurate. All right, I want you to tell me what is the domain of our translated parabola. What is the domain of our translated parabola looking at our graph? Sarah, right? Yeah. Sophie, okay.
X equals all real numbers.
You got it. X such that we have all real numbers. What about our range? What is our range here? Tice, what do you think the range is?
Greater than 0.
But look, so we're looking at our graph. So greater than 0 would mean we're here, or here, or here, or here, somewhere on the x-axis, but we're not. So we're now starting the graph at this point right here. So if this is 0, this is 1, this is 2. So we're not greater than 0, we're greater than 2. Does everybody see how we got that? Y is greater than, can it be equal to 2, Tice?
Yes.
Yeah, greater than or equal to 2.
So it's really about looking at what you have on the x and y axis.
All right, let's do another one.
5 minutes, miss.
5 minutes? Okay. We're going to talk about the translations for the absolute value. So now we know our parent graph is y equals the absolute value of x. And y equals the absolute value of x. Is it the parabola, the V, the shooting star, the disco dancer, the 2 like curves in the different locations? Which one is the absolute value? The V. So that's our parent graph. Now let's talk about the translations. So for the translations, we're going to have y equals a, absolute value lines. Inside the absolute value lines, x minus h, close your absolute value line, plus k. So essentially, the translations for the absolute value are following the same rules as the translations for the parabola. So remember, a, for the purposes for our purpose, is positive opens up, negative, open, down. Okay, the H will represent our horizontal shift. X minus H to the right. X plus H will be left. And then K represents our vertical shift. Plus K is up. And minus K is down. All right, I guess we'll stop here and I will give you back your quizzes and we'll go over them if you need me to.